So now let's go ahead and talk about a horizontal shift. This is something that is sometimes a little confusing because it almost seems like it works backwards. So we'll look at an example. Now I have f of x here, and I've identified that the parent function is just the square function, p of x equals x squared. Well, what that means is that I can go ahead and rewrite this in terms of the parent function. P of some input is equal to that input squared. Well, if I plug in an x plus 3 here, well, then I end up with P of x plus 3 is equal to the quantity x plus 3 squared. So I can replace this x plus 3 squared here with P of x plus 3. So now what I've done is I've written my function f of x in terms of the parent function. Okay, so let's use that to then come up with some values and analyze what's going on. So first I'll try just plugging in f of 0. Well, that's going to be equal to P of 0 plus 3, again just replacing the x with the 0, or P of 3. So I know that when I input 0 into my function f, I can just look over here to P of 3. The input 3 gives me a value of 9. So I'm going to come up here and put that 9 there. Now I'm going to do the same thing for a few other values. So I'll do that for f of 1, for example, is going to equal P of 1 plus 3, which is equal to P of 4. So if I want my output for f, when I have an input of 1, so this spot right here, I'm going to go down to P of 4, and that outputs 16. So I'm going to put the 16 here. And if I continued this, what we're going to see is a nice little pattern. So what's really happening here is all of these are happening sooner than they normally would. So the parent function doesn't hit an output of 9 until time of 3, or an input of 3. But I'm hitting that 9 with an input of 0. So I'm going backwards by 3. And you'll notice that if you do that for all of our values, if I look at the input of 4, I get 16. And if I go back 3 units to 1, I get that same 16. So everything's happening 3 units sooner than it normally would. And if I fill in some of these other values, we can kind of see that a little more clearly. All right, so what can we really gather from this? Well, it turns out that this plus 3 here is actually shifting us 3 units to the left. And I'll show you an easier way of calculating that, but let's just graph this series of values that I calculated here, and we can see that pretty clearly. If I start here in the middle, I've got negative 3, 0. Okay, and then I'll just go ahead and plot them and you can kind of follow along. All right, and so that's some values to plot. I'm not going to plot all of them because I want to show something in a moment, but if you notice, all of these have shifted over negative 3 units. All right, well, what's an easier way of doing that? Well, when it comes to a parabola or a squared function, what we're going to see is one of the most important values is just the vertex here. Now we know that the vertex of any parabola is just at 0, 0. Or in other words, we know that when I plug in 0 into my parent function, I expect to get a 0 output. So what we want to do is figure out when our function f is going to have a 0 input. Well, cool. So let's find that vertex then. So instead of it being simple and having an input of x, we need to now figure out when x plus 3 is going to equal 0. Perfect. So now we know that x equals negative 3 is when we are going to get our vertex. Well, if that's the case, then our input for the vertex went from normally being 0 to being -3. So it went from 0 to -3. Well, that's a shift 3 units to the left. And what we're going to see is sometimes we'll combine together multiple transformations. So this idea of figuring out when the input is going to be equal to 0 is going to be a kind of a universal way of figuring out our horizontal shift. Now, once we have that, instead of going through and using this table for everything, what we can do instead is just pick a point on our parent function and shift it over 3 units. 1, 2, 3. Pick another point, shift it over 3 units. 1, 2. So using these transformations, we can more quickly figure out a basic sketch of our graph.